2A, explain any 4 dynamic allocation function with syntax and example. They have asked for 10 marks. Dynamic memory allocation is nothing but we are going to allocate the memory for our data items manually. That we call it as dynamic memory allocation. Okay, and how much ever memory space is required, that much you will allocate. And if you feel like you want to delete that is also possible in this dynamic memory allocation. So we do not have any special technique to do this. We have 4 functions, library functions under the standard lib.h for dynamic memory allocation, that is malloc, calloc, realloc and free functions. 4 functions are there that will help to do the dynamic memory allocation. First, malloc. Malloc is nothing but it allocates the memory requested size of bytes and return a pointer first byte of allocated space. So this will help you to allocate the memory, and only single block of memory will be allocated using this malloc function. Calloc function is also an allocation. This also helps in memory allocation itself. However, this will initialize to 0 and then return a pointer to the memory. In both of the cases, it returns the pointer to the memory. Free function, whatever you have allocated the memory, if you feel like deleting that memory space, then we use free function. This will deallocate the previously allocated space. Realloc function, whatever you have allocated, might be there is any changes required in the size of the memory space, that allocated space, then we go for the reallocate function. The secondly, now firstly we have to explain in detail the syntax, example and the functionality. They have asked in the question, right, along with the example. So malloc stands for the memory allocation. As I've told you, it reserves a block of memory of the specified size and it will return you a pointer of type void which can be casted into pointer of any form. See, the syntax is like this: pointer is equal to cast type star malloc byte size. The example also will be similar only. Cast type means any data type. Here we will take it as integer pointer malloc byte size you have taken 100, size of integer you have to take, means is it 4 bytes, integer will take 4, right? That we have to, that will be the size of this data type. So see, calloc means contiguous allocation. The difference between the malloc and calloc is that malloc will allocate single block, whereas calloc can allocate multiple blocks of memory. Here you can see the syntax: pointer is equal to cast type star. Cast type is nothing but it can be int, char, float and so on. Calloc, this is the function name. You have to specify the number of blocks and the element size. Here 25, the size of float you have to take, so we are taking it as a float, right? That's why. Now let us go for the realloc function. Realloc function is nothing but this will help you to change the memory size which is already allocated. Might be that it is insufficient. Before, whatever you thought that it will require only 1 byte and you are allocating 1 byte of memory, but it may be required of 2 byte of memory, or it may be the case that you have specified 100 bytes of memory but it requires only 1 byte of memory. In such cases, no need to waste the memory or loss of data and so on. We will go for the realloc function. Syntax will be pointer is equal to realloc, pointer new size, which pointer you have to change the memory allocation that is possible. Realloc pointer is 50. Next, free function. This free function helps you to delete the allocated memory space. The whichever dynamically allocated memory created using the calloc or malloc only, you can do that, right? That cannot do it on its own. It cannot delete by itself. You have to use this free function explicitly, then only the memory will be deleted. I mean that particular space, allocated space will be deleted. Syntax is very simple: free pointer, free the pointer 1. So second 2B question, this also they have asked for 10 marks. What do you mean by pattern matching? Outline the KMP algorithm implement same to find out occurrence of following pattern. So the pattern is this one, the string is this one. What our thing to do is we have to check whether this pattern is present in this long string or not. How can we do that? We'll see. This is the question. Now firstly let us answer what do we mean by pattern matching. Pattern matching is the process of checking whether a specific sequence of characters or token or data exists among the given data. This is the given data now. For us, this is the given data. This is the pattern. Now we will check whether this particular pattern is present in this longest string or not. Okay, in that to do the pattern matching we have many techniques. In that now we have to discuss is about KMP algorithm. Using this KMP algorithm we have to do the pattern matching. What is KMP algorithm? This algorithm will check the character from left to right. It will check from left to right like this. Okay, A, B, B, C, C. This is left to right, right? Using this KMP you can do that. When a pattern has a sub pattern appear more than one in a sub pattern, it uses that property to improve the time complexity also for in worst case. It is not that only one time this given pattern should exist, as it is a longest string. They maybe one time it may appear, two times or n number of times it can appear till the last element or character. This pattern has to be checked. That is important. Next we'll see the algorithm for this. Algorithm begins like this. In the KMP algorithm, begin length is equal to 0. What is the length of the string? Let us consider initially it is 0 and our pattern is also 0. For all the characters index I of a pattern, do if pattern I is equal to pattern of length, then increase the length by 1. Meaning here we can see to that if it is matching, if it is AA, it is matching, right? If it is matching, increment the pointer to next one in the pattern. Also increment the increment to the next character even in the string. That is what we mean here. Suppose else if length is not equal to 0, then length is equal to preferred array or length minus 1. Decrease I by 1. Here we can see that it is matching. If it is matching, move the pointer to the next. Here also you should move up and down, both also you should move for both pattern and string. C is also matching. C is matching, yes. Increment the pointer to the next. Here also increment the pointer to the next. You can see to the here it is mismatching. D and A is not matching. In that case what you have to do, if it is not matching, then length is equal to preferred array of length minus 1. Here which is not matching, right? Here it is not matching. Then in this string, in this particular, I mean this one, in this one you have to one step go backside. This is called as backtracking, and you have to check whether it is matching. Again it is not matching, then what we will do? If this you will be doing until it is equivalent, else you have to make it as 0, done, end. Now let us take one example and check as they have given the pattern, we have to check for that. In the question itself they have given the pattern is ABCD ABD. For this now what we have to do is firstly let us find the make one table. We have to make one pi table for the KMP algorithm. In order to make the table you need this chart. Firstly what you have to take is string length, string, prefix, suffix, length of matching string. String length we will go by left to right, right? So we will take string length 1, string length 2, string length 3, 4, 5, 6 and 7. Firstly let us take string length 1. String length 1 if I take, I have to consider only the length is, first one is what? A. Only one element I have to take because length is 1. String also should be one element, one string only should be there. For string A, prefix and suffix you have to find out. Do you find any prefix or suffix? Prefix means something which exists before of A, that is prefix, and something that exists after the A is called as a suffix. Next to before of A anything is there, nothing is there. After A anything is there, nothing is there. So the prefix for A is A itself and the suffix for A is also A itself. Now what we have to do is the length of matching string. Now we have to compare between the prefix and suffix. Is it matching or not? Since it is existing on its own, there is no prefix, no suffix, it is only the own thing, we will take it as 0. Second time, string length we will take it as 2. Now we have to consider AB because string length we are considering is 2. AB. Here the first element you can take it as prefix A and suffix will be B. Lastly coming one will be your suffix, right? Now we compare A, B. Is it matching? No. So it is 0. Now you take it as string length 3. What is the third? What will be the string? ABC. ABC. What will be the prefix? It can be only A. It can be AB. In prefix, the last element you should not consider. This is the prefix of C. It can be A or it can be AB. In suffix, C will be the suffix. See, one shortcut is in prefix you will go from left to right. In suffix you should go from right to left. In prefix, last element you will not consider. In suffix, first element you will not consider. See, in prefix A it can be A, AB, and in suffix it is only C or BC. Don't write it as CB. It is BC only. C or BC. Compare now. A and C, is it matching? It's not matching. AB and BC mismatch. So 0. Now let us take a string length of 4. ABCD. What will be the prefix? Leave only D. All other elements you have to take only A. The prefix can be only A or AB or ABC. What will be the suffix? D or CD or BCD. So is any element is matching between these two? A and D is matching? No. AB and CD is matching? No. Matching means it should be same. Is it same? Anything is same here? No. So it is 0. Now let us take a string length of 5. A, B, C, D, A. As they have given the pattern, that one only we have to consider. Okay. It can be A, AB, ABC, ABCD. Only the last element you should leave in the prefix. In suffix, first element you will leave. Go in the reverse order. A, D, A, C, D, A, B, C, D, A. Here now we will compare the prefix and suffix. What are matching? Here also A is there. Here also A is there. So the matching string length you will take. What is the string length of this? This is the string length is 1. So take it as 1. Next one, string length is 6. A, B, C, D, A, B. Same thing. What will be the prefix? A, AB, ABC, ABCD, ABCD, A. Leave only B in prefix. Whereas in suffix, leave only A. Go in the reverse order. It is B, AB, D, AB, C, D, AB, B, C, D, AB. Okay. Now compare prefix and suffix. What is matching? Only AB is matching. What is the length of the string? It is 2. A is 1 length, B is 1 length. So it is 2. So make it as 2. At the end you have A, B, C, D, A, B, D. Same thing, prefix you have to take it as, what will be the prefix? A. It can be A, AB, ABC, ABCD, ABCD, A, ABCD, AB till here. Only the last element you have to leave. In suffix what you have to do? Go in the reverse order. D, BD, ABD, DABD, CD, ABD, BCD, ABD. Compare. Any matches there? No matches there. So take it as 0. The pi table will be like whatever the string they have given, A, B, C, D, A, B, D, that we have taken. Index you have to number it as 1, 2, 3, 4, 5, 6, 7, and whatever the result you have got here 0, 0, 0, 0, 1, 2, 0, that we have to mention here. Okay, that you have to note down. Now the given string is ABC, ABCD, AB, ABCD, ABCD, ABDE. Pattern, our pattern is this one. So our pattern, we derived one pi table, right? Whatever we have derived, this is pi table, and this is 1, 2, 3, 4, 5, 6, 7 is nothing but the index we have given. Okay, so we will put 2 pointers, one pointer for the given string and one pointer for the our pattern. Okay, j is equal to 0, we will start with 0. Also for the given string you take the index. Index starts with 1, 2 and so on till the given string. You have to take the index. Compare. We will compare both. A, is it matching? Matching. Yes. B, then if it is matching, increment the pointer. I is also incremented, J is also incremented. Is it matching? B is matching, yes matching. C is matching, matching. D and A, is there any match? No, there is a mismatch. If it is mismatch, one step back you have to go. One step back is what? C. In the C, what is the value we have got? 0. If it is 0, it is showing 0, so go to 0. From the beginning you have to match. Then now you have to match with the A. Is it A is matching? Matching. B is matching? Yes. C is matching? Yes. D is matching? Yes. A is matching? Yes. B is matching? Yes. D is matching? No, it's not matching. D is not matching. So one step go ahead. It is B. 1 minus 1. So before D, what is that? B, right? Go for the, what it is showing? Showing 2. In the index 2, you have to start. B. Again you have to compare and so on. You will be comparing such a way that and find out where our string is. If you keep on repeating this step, you will find here like A, B, C, D. It is matching here. So in order to find the index, how to find where is our string, you can find is once you have allocated this one, I minus length of pattern plus 1. I is what? The length of the string. The length of the string till where it exists, till where our pattern exists, that only you have to consider. See, the total length is 23, but our pattern exists till 22 itself. So consider that only. 22 minus length of pattern is 7, isn't it? Our given pattern is 7. Take it as 7 plus 1. Do it. 22 minus 7 will be 15. 15 plus 1 is 16. See here, the index, in the index 16 our required pattern exists. Check here, in the index 16 only our pattern is existing. A, B, C, D, A, B, D. Also the time complexity of this KMP algorithm is big O of M plus N.